So for question number 2, given the mass is 15 kg, so we need to find the tension value. The first step is we must draw the free body diagram. So we have a tension and a weight. So we must calculate the weight by using the equation below, and we will get the weight is 147.15. So the next step is we can calculate the tension by using xy component. So since the x component doesn't have any force, so we just calculate for the y component. So the y component total is equal to 0 since it is in equilibrium. So we know that the y component is consists of t sine 60 plus t sine 60 minus by weight equals to 0. So we can factorize the sine 60 and we will get tension plus tension equals to like this minus by, we can add the value of weight here, that is 147.15 equals to 0. So then solve the equation as usual, and then we will get 2t equals to 147.15 divided by sine 60, and we will get the value of 2 tension is 169.91. We want to know the value of 1 tension, so we divide it by 2 and we will get the value is 84.96 Newton. So that's all.
So for question number 3, given that the mass of the block is 2 kg and the mu coefficient of static friction is 0.2. So I've drawn the free body diagram here where the friction will be upwards because it will slide down, and there is also weight and force that will act onto the block and also resultant force opposite of the force. And then the questions want us to find the value of the force. So if you guys see here, friction is the same as weight, while resultant force is the same as force. And then, as we know, we want to find the force. Therefore, we will use this one, which is mu r equals to mg, and we will substitute the value of mu 0.2 and also r, where we want to find the value of it since it is the same as f, and also mass of the block and the gravity 9.8. So lastly, you will get the answer 98.1 Newton, where R is the same as F. So that is all.
So for question number 4, given that the coefficient static friction value is 0.30, so we want to determine the maximum force that this man needed to make the block at rest. So the first step is to draw the free body diagram. And then we calculate the weight value as usual. We will get the value is 490.5 Newton. So the third step is to calculate the x and y component. We know that the total Fy component is equals to ma, but since the object is in constant velocity, so the acceleration value is equals to 0. So the total y component is equals to 0. Thus, the Fy component consists of r minus w cos theta equals to 0. So then we just substitute the w value, and we will get the r value is equals to 424.79 Newton. So for the x component, the total x component is equals to 0. And then we know that the fx component consists of force minus by friction equals to 0. So we will get the F equals to friction. We can find the force value by finding the friction value. So we know that the friction is equals to mu r. And then we will just substitute the value, and we will get mu equals to 0.30 multiplied by 424.79. And then we will get the final value is equals to 127.4 4 Newton. So that's all.
So for question number 5, given that a mass of object 2 kg moves with constant velocity towards east, two forces will act on the object. One will go towards east and another one will go towards west with 40 Newton. So they want to know what is the second force that will act on the object. So as we know, constant velocity will have acceleration is equals to 0. So if we want to find the second force, therefore we use the fx component equals to ma. And since velocity is constant, so a is 0. So as we know, F2 minus with 40 Newton, since already stated that towards west is 40, is equals to 0. So the second force is equals to 40 Newton as well.